should introduce myself, of course. Didier Van Hoye, better known as Working Hard in IT, Microsoft MVP, and a lot of other stuff. But let's skip it and talk about what QUIC is. So QUIC is, it used to be an acronym, and it's, well, let's say it used to be an acronym for Quick UDP Internet Connection. Now it's just a name without a meaning. It's a Google standard, so to speak. They invented it, and they want to connect to the internet via UDP instead of TCP. And they've got good reasons for that. They want more performance and less congestion. And they want to do that in a way that you keep all the benefits from TCP. So it should be very reliable, like we know from TCP, and applicable all over the world. The good thing is QUIC is based on HTTPS 3, so that means TLS 1.3, so it's always secure. Everything is in a tunnel, so that's one good thing. Microsoft created their own version of it, MSQuick. They open sourced that, and it's available to anyone who wants to use it. And the takeaway here is this is not just for internet browsers, but you can use it for different things like DNS and SMB. And SMB is what we will talk about here today. Now, why is QUIC so great? Well, you know, it reduces the connection times. And you might think that's not that important, but if you're a cloud scale player like a Google or an AWS or a Microsoft Azure, that becomes important. So TLS 1.3 actually is what delivers that. You can see that compared to TLS 1.2, TLS 1.3 is a lot faster, but QUIC is the master at the game. And it becomes even better if you have resumed connections. It becomes zero round trip, right? That's cool. UDP, why UDP? Well, what you know from remote desktop protocol, what you know from gaming, if you want to have performance over, let's say, less reliable networks, UDP is great. Well, hence they turn to UDP. And it's also going to give you a lot better performance in case of packet loss, and that's due to how it handles head-of-line blocking. And I know this is going to be vulgarizing it, but these are the big three types of HTTP. So HTTP1, if you wanted to send data across, you would have a connection open. And if you wanted to do more stuff, you would have multiple connections open. But a lot of TCP connections means a lot of overhead. It doesn't scale. It doesn't perform as well. So then HTTP2 came along, and you had multiple streams inside of a single connection. Now, this is really, let's say, vulgarizing it, but at the application layer, that worked fine because that can handle all that. But if you go lower down at OSI stack, you come to the hardware, and basically you have a problem. If one of the streams, let's say the yellow stream, drops a package, then all the other stream, the red stream and the blue stream, will also have to wait. So that's not the application layer that can handle it. It's basically lower down the stack. Now with QUIC, you really have multiple independent streams within a single connection, and that is what makes it a lot more resilient to head-of-line blocking. Now, the goals of QUIC, what else do we have? Connection reuse. So you might even send multiple requests over the same connection. Good example of that would be DNS. DNS tends to do something and close the connection. Well, if you reuse a connection, you can send multiple requests over that same connection. Easy connection migration is really nice because if you switch networks from access point to mobile data, vice versa, you don't have to establish a new connection. That's what TCP/IP needs, but QUIC doesn't need that. So it makes it a lot easier and a lot more reliable from a customer's perspective. And then again, you can develop QUIC in the user space if you want to. You don't have to, but you can if you want to. And that makes it very interesting because, hey, if you write in, let's say, for TCP/IP, you're in the kernel, and that can be a bit tricky. So it allows people to develop applications quicker, and it's detached from the operating system. So if you want to write an application that uses QUIC, you're not tied into what the vendor is doing with, or the producer is doing with its operating system, whether it's Windows, Linux, or whatever. So that's kind of cool. Now, there are some concerns with QUIC, and one, of course, you might think about is if you think about advertising in Google, that they invented this to track you even better. They can do that via the zero round trip feature, the session resumption. Basically, that is replayable. That's not protected by perfect forward secrecy. They can use tracking by the configuration of their servers, and your web browsers normally, well, they don't protect you well enough against all those things. But, I mean, if you look at the internet and privacy concerns, they can track you in a zillion ways. And yes, this can also be used to track you if you configure it wrong, if you use it wrong. There's potential there. So that's one concern. The other concern, which is a bit more FUD related, is there were a lot of security critiques on QUIC. You know, there was this thing like, oh, our firewalls are blind now. They can't see anything anymore. You can't do TLS inspection anymore. So you don't have the visibility in what your app is doing. You can't control this. It might break systems that do denial of service attack preventions because those are based on UDP, etc., etc. Now, it isn't as bad as it sounds. There's a lot of FUD there because a lot of the things that they mention here is based to the perfect forward secrecy. And you had that in TLS 1.2 as well. You could enable that. It wasn't mandatory. In TLS 1.3, it is. So that's an issue you're going to have if you start using that anyway. And those security vendors, they just have to keep up, implement controls for that. And basically, you can still do that if you put yourself as the man in the middle and decrypt everything and re-encrypt everything in the middle. But you can't just drag the data off to the side and decrypt it there because perfect forward secrecy will not allow for that. And on the other hand, you have to think about it. What do you mean with security? You mean you can't control things? Or if you can't see things normally because they're encrypted, it's quite secure. So there's a bit of a discussion you could have over that. Now, there are some challenges to the adoption of QUIC. Some people will say, well, I don't need my app to be 3 times faster. Why would I even bother with QUIC? And that's fine. It's not for you. Doesn't mean anything. But if you are a cloud provider, you might think differently because all those little benefits, they add up if you do that at a large enough scale. Likewise, people will say, well, that reconnection issue with my mobile phone or whatever, I don't have any problems. Well, good for you, but a lot of people in the world have. Performance, it's not up to, let's say, it's not the same as with TCP. That's true. You can't do 100 gigs or 25 gigs today, but do you really need to for the use cases we are looking at? And secondly, it's very early days yet. And Microsoft, there's a link in the slides, is doing a lot of things to make it more performance, and they are also working on a lot of UDP offloads and scaling mechanisms, and you will see those appear in Windows Server 2022. So, the inertia and the thought, well, there's a lot of benefits that some apps might say we don't need it. That's fine. That's inertia, or that's a valid reason. There's a lot of endpoints in the world that might be using QUIC, but if you look at IoT and sensors, you're very lucky if they talk TLS altogether, let alone that they are already able to do QUIC. And then security appliances, some of them will have a mental breakdown because they are just, one, not suited for true security because they're a bit of a, let's say, they have a different business model, or because, well, people are panicking and, well, they think they have to block QUIC and, to secure the company, but that's not really true. There are some valid challenges. The internet routing has to be adapted, but that's already being done. Otherwise, UDP would not be in such high use with Google and other providers like Cloudflare. And there are some things around NAT and equal cost multipath that need to be figured out. But again, they are also doing that. The industry is not standing still. And what couldn't be done 5 years ago is quite possible now. So why use SMB over QUIC? What drove Microsoft to do this? Well, there's 2 things you need to look at from the user side. So think of it, if you're using UDP over 443 instead of TCP 445, any one of you who has worked with Azure might know that, hey, that's often blocked by an ISP or the corporate firewall. Getting rid of the head of line blocking is good for performance for the user. The easy network change and the more stable connections are also very important. And the transparency is a godsend, right? You can access your file shares over the internet securely without needing a VPN, as if everything is the same as you're in the corporate office. And from an engineering perspective, right, reducing that TLS overhead, cloud scalers, they love it. UDP, all that overhead you have with TCP, you get rid of it. So again, cloud scalers, they love it. End users also love it because performance is better. Then there's the easy development and adoption because you can develop in user space, and it's a lot more firewall friendly. So what are your use cases? Well, everybody nowadays, right? Telecommuters, road warriors, you work from home, you work from anywhere, totally VPN free and no firewall issues or ISP issues that are blocking you. Because thinking that somebody would be silly enough to open 445 over a firewall on TCP is, well, it's not going to happen. From a corporate or business perspective, all your Azure file shares that were blocked by those firewalls, hey, they now work, right? Because it's UDP 443. And before you think, hey, wait a minute, isn't that blocked by default on many firewalls? Well, apparently not. Many years ago, Google tested it, and they noticed that over 80% of all people, all businesses do not block it. And that's why it's being used so much. All this is relieved by QUIC, so basically that's why they love it. Now, SMB over QUIC doesn't throw out anything, so TCP, RDMA, it will all work. It's just a new option you have on the client side and on the server side. This is all happening over TLS 1.3, so that means it is secure. So if you are on your corporate LAN, and normally you have TCP 445 enabled, and if you want to, you can enable UDP 443 on your file shares, and they can use either. You can enforce one of the other. That's all possible. That's what you know, but you added QUIC. On the internet, normally TCP 445 will be blocked, but you will have UDP 443 open, so then QUIC will be used. And basically, that's what we do in the lab. We block 443 on the file server. We block it on the firewall. We just force QUIC that way to show you in the labs later on in the demos how it is happening. There's a little thing here that's called a KDC proxy, and that will give you something else. That will give you, well, Kerberos authentication over the internet in a secure way, and that's also very nice. Another important little icon here is a certificate you need, and if you talk about certificates, you need to be aware that those certificates will have a CRL, a certificate revocation list, which you will need to be able to get to in order for all this to work. So the big thing is the security. So where can we use it? Is there another thing that we might need to discuss? Well, where can we use it today? Well, we can use it on Windows Server 2022 Data Center Azure Edition, which actually only runs in Azure IaaS VMs, if you select that version, or on Azure Stack HCI. And then you get into some of a licensing pickle because you need to license it, and that might not always be the cheapest option. Windows 11 has an SMB over QUIC client, and that's it. So one of the challenges, one of the major roadblocks to adoption, in my opinion, is the fact that, well, it's either Windows 11 as a client. You could use Windows Server 2022 Data Center Azure Edition as a client, but due to the fact that the only one in Azure IaaS and on Azure Stack HCI, that's not really always feasible. So, and also thinking that people will move there very fast is maybe a bit optimistic. Now, is that it? No. When I was writing articles on SMB over QUIC, a company reached out to me and they let me play with some of their libraries, which actually opens up QUIC on any client in the world you could imagine. So that was kind of fun. I have this running in the lab, and I'll show you a demo. The company is Visuality Systems. They have a couple of libraries. I'm not going to go into details, but what I was able to do is I have QUIC connections to my QUIC files share on Windows 10 with their library. Hey, I've got QUIC running on a Linux Ubuntu desktop, going to my Windows file share. Okay, so now we're talking. You could use this in embedded system, in IoT devices, in scanners, in anything you could imagine. So Android phones. Yeah, I got the Android client to play with. Look at that. I have SMB over QUIC on my Android phone, and I can access my file shares via SMB over QUIC securely over the internet. Kind of cool. One of the things we were playing with as a design is, well, what if I don't run Azure Stack HCI on-prem, but ordinary file servers? Well, I could get them into Azure via Azure File Sync. In Azure, I could run my Windows Server 2022 Data Center Azure Editions machines, expose my endpoints as SMB over QUIC, and then I can connect to them via my Windows 11 machine. But if I use third-party libraries, Linux, mobile devices, any device in transport, in the aerospace industry, insurance agents in the field, medical scanners, you name it, right? It's the sky is the limit almost. But let's discuss how to set this up. And this could be a bit of a boring part, a bit of a technical part. But the thing here is NetPile made a really nice video about the subject. I've got the link here. And I'll run through it very quickly, way too quickly to be good, I think. But of course, what you're going to do is you could use a third-party certificate provider, and that's fine. Or you could use a self-signed, but when you use self-signed, you're going to run into issues because they need to be validated. Now, you can turn off certificate validation, but that's not something you want to do in production. So if you want to play around in the lab, you either find yourself a free certificate from a third party, or you use your PKI, and in your PKI, you will just duplicate your computer template, put it on the maximum compatibility settings you can find in the compatibility tab. You give it a name, you publish it in Active Directory, you make sure that the purpose is a signature in request handling, and in cryptography, you are going to go for the modern stuff, right? Don't go to SHA-1 or whatever. It's not going to work. Just use the modern stuff you can find. Make sure you have server authentication in the policies. Allow authenticated users to read the certificate template so they can create one, and make sure you allow people to enter data like the DNS names you want to use when they request the certificate. What you're going to do is then publish that certificate, and hello. Once you've done that, you can, on a file server, say, I want to request my user certificate. You're going to go to your Active Directory enrollment policy because you've published it there. I've got my SMB over QUIC template here. I'm going to fill out my CN name and my DNS names. These are the ones I'm using in the lab. And that's it. I've got my certificate. That's all there is to it. It's pretty easy to do. So now you have a certificate, you can start configuring SMB over QUIC. So I've just realized I didn't turn my camera to my face. So if you're missing out on something, let me see if I can fix that for you. Okay. Wouldn't want you to complain to the organizers that you didn't see my nice face. Right, so here we go. So configuration. There's two ways to do this. The hard way in PowerShell and the easy way in RAC. In RAC, it is really that simple, but in PowerShell, it's not that difficult either. Basically, everything you need to know is already in the screenshot here. Now, in RAC, you have to have a modern version of RAC, but if you have it installed and it's set to auto-updating, you should have that already. If you go to the settings for a file server, you will find under file shares that you can configure it SMB over QUIC. And then you can enable this via edit, and you can also even enable your KDC proxy. The KDC proxy is very little known to people, and it's a bit tedious to configure, but via RAC, they make it very simple. Although I did run into some issues with this in the lab, but I got it fixed just in time for this presentation, but we're going to look at this later on. Anyway, let's go to the PowerShell. I will share this on my blog. I've written this in articles. So basically what I'm doing here is that certificate we just created. I'm grabbing the thumbprint. I'm putting in all the DNS names of my certificate I want to use. And I am going to map that certificate with the name, with the DNS name, to my SMB server. And basically, that's all there is to it. It isn't that hard. And if you want to remove it, it's just the reverse process. You just remove the certificate by using the thumbprint. And you say which DNS names you want to get rid of. Well, you've already got them here in the parameter, so you're good to go. What you can also do is you can, with the SMB Client Configuration and the SMB Server Configuration, state what you want to do. Do you want to enable QUIC or disable QUIC? But if you did not enforce QUIC via the firewall by blocking TCP 445 and allowing UDP 443, you can also in PowerShell or NetUse state that you want the transport type to be QUIC. And that's two examples of that you have here on the slide. And if you look at the client configuration, right, skip certificate check is false. You can set that to true, but only in the lab, people. Force SMB encryption over QUIC, also by default set to false. Well, everything over QUIC is already encrypted via TLS 1.3. So you don't really need encryption. That's why it's by default off. If you look at the server configuration, you can enable or disable SMB over QUIC. You can also say, I don't want SMB encryption if my connection is secure, etc., etc. You can play around. How do you play with this in the lab and in the real world? Well, you're going to force QUIC so you can really watch it come in. So what you do is you block TCP 445 on the firewall. I've also set up a KDC proxy on your firewall in the lab or the corporate. You make sure that your test clients cannot talk TCP to your file share. And what you also do, if you have a segment where you want to emulate the internet, you make sure that you cannot reach AD at all over that segment. So that's blocked off. So you will have to use the KDC proxy, but we'll show you that in the lab. Now, SMB over QUIC can and will use NTLM v2. Why? Because it's very, very convenient, right? Because if you're out on the internet, guess what? You do not have a line of sight to a domain controller. Another thing is, a lot of the clients, especially if you use third-party products, will not have a domain or a domain controller. So NTLM is there, and it works quite well. The dead giveaway is that you will be prompted for your username and password. But on the other hand, going into a corporate meeting in 2021 and telling a CEO and especially a CISO that you are going to implement something with NTLM v2 in 2021 or 2022 is called regression. So what they want is Kerberos, and that means Active Directory domain controllers. But there is no way on earth that you are going to expose your domain controllers to the internet. So how do you fix this? Well, the KDC proxy. The KDC Proxy Service, what is it? Well, quick recap. What is a KDC? A key distribution center service runs on every domain controller, and it does two things. It provides authentication, and it gives you the ticket granting service. So you get a ticket granting ticket. So in the end, that entire process is needed for mutual authentication between client and server. And if you are authorized, you can access the server on that machine. So basically, this process is never exposed to the internet. However, if you put a proxy, excuse me, if you put a proxy between your domain controllers and your user, hey, now all of a sudden you have a KDC service running over HTTP 443, and that is secure. Mind our CRL OCP server. These need to be reachable, otherwise this entire process will fail, and it will fail hard and bad. Configuring the KDC proxy, as I mentioned, you can do this now in WAC. This is actually the entire process that you need to do if you do not have WAC. I'm not going to read this out loud. You can have the articles online, you can have the slides, you can play with it to your heart's content. Sometimes I make typos. Typos are important. If you find one, let me know, then I can fix them. But basically, these are the steps to configure it. Once that is done, there's two things left to do. You will add your computer aliases via NetDOM. So that's a lot better than using CNAMEs in DNS. And then you have Kerberos. And you will have to start the KDC proxy on the server where you set this up. And if you look on a Windows server since when? Since 2012 or 2, you will find the KDC proxy disabled. It's there. But unless you are running it for RD Gateway or for direct access VPN, you might not know about it or ever heard about it, or let alone configured it. The cool thing is those are actually the only two things that are supported with the KDC proxy service. Microsoft likes to talk about the KDC proxy service for SMB over QUIC, but I've never found a document that states officially that they support it. So that's kind of funky. Once you're done configuring it on the server, you have to tell your clients to use a KDC proxy. And you can do this with a group policy, or you can do this in the registry. The registry might be interesting if your clients are out in the field all the time and you don't get to deploy GPUs, but you have some other means of deploying settings to the machines. You can just fill it out in the registry. Again, everything here is very case sensitive, space sensitive, and there's even a typo here. There should be small letters here, not capitals. So if something doesn't work, you've messed something up left or right. And there's even a mistake, as I said, here on the slide, now that I look at it. On the client side, you can disable certificate revocation checking, but again, only in the lab. So do not disable this for SMB over QUIC, nor for the KDC proxy in real life. That is a very bad idea. But for testing, troubleshooting, lab work, you might always do it. So is the KDC proxy being used? Well, there's a lot of logs. The KDC proxy operational log we can have a look at, and we'll take a look at it when we are in the lab. You can look at the ticket granting tickets you get. And last but not least, once you've set up that KDC proxy, you get the advantage that people get to change their password over the internet, all for free in a secure way. And in times of telecommuting and Corona, that might be an extra useful benefit. But, you know, that's a lot of talk, and I've got cool demos. So let's go there. Let's see if we can get this out of the way. And let's start looking at a couple of things. First of all, this is my Windows Server 22 Azure Edition version. And I have my Wireshark running. And as you can see, I'm already generating QUIC traffic. I'm seeing QUIC traffic coming from Polar Bear, and it's coming over FS QUIC. And what else do I have here? My file shares, very important, of course. And my, let's see here, my KDC proxy. We're going to look at this. And when the KDC proxy is being used, you're actually going to see these entries here, that a request was received and that it discovered a KDC for me. Keep that in mind. What I'm also doing is on domain controllers, I've put on NTLM auditing just for the purpose of being able to show you. See, here we go. Where is my domain controller now? It's gone. Oh, different screen. My apologies. Yeah, I have a policy open to define my KDC proxies, but otherwise what I have here is my NTLM operational log. And that's what I'm going to use to show you when NTLM is being used versus the KDC proxy, right? Okay. I have two clients in play here. One of them is my QUIC client. Basically, this is either Windows 11 or Windows Server 2022 Azure Edition. This machine is not on the corporate network, but it is domain joined. And I logged in with my domain credentials. It didn't find a domain controller, so it went to a KDC proxy. And if you do klist, you can see that the KDC called was the KDC proxy and not a domain controller. But this is the dead giveaway that you are using a KDC proxy. As you can see, it's already generating some QUIC traffic as well. But I can go to file shares. I can open documents. I can type in documents. I can save them. All no problem. And it's all transparent to the end user. It's just like he is in the office. There's a little bit of a delay when you're logging in because the KDC proxy is only used at the moment that the machine decides it cannot find a domain controller. But that's inevitable. And you can see all of this happening here. And let's try and open another file share. Let's see. Business plans was one, I think. Yep. Here we go. Let's open another document. What we are doing is just generating some traffic to see if we can, oops, wrong one, if we can see that the KDC proxy is being used, but yeah, 2152, that's us. We just did it, right? That's us. That's the latest one. So you see the KDC proxy in use. Now let's try something different. Let's go to that Ubuntu desktop. You can join it to the domain. You must not, but you can if you want. And here I have two applications running. Again, as you can see, QUIC traffic is going to the file share. I can run NTLM, which is this one, and I can run with the Kerberos proxy, so with the KDC proxy. It has Kerberos support. Well, the proxy is not in there yet in this application, but Kerberos support is. So if I use this one, I am authenticating to a domain controller. If I'm using this one, I'm just using NTLM v2. So let's use this one. And why? Because I want to generate some NTLM traffic for you to show that really this is NTLM. So let's create a folder. And the desired folder name, MC2MC, for example. There we go. Let's create a file in that folder and mc2mc.txt. There we go. What can we do with that now? We can open a file. We can create more files, delete folders. We can do whatever we want. So if we open the file, I want to write data to it. Let's write some data there. Okay. Now let's close the file. Let's 0. Enter program, and we're done. So let's go and have a look at our file server. And normally we should. Oh, where are we here? File shares, sales. Hey, created a folder, we created a file, etc., etc., etc. Now, the cool thing is, if we go and look at our domain controllers, look at the timestamp here, 2952, 29, I think this is us. You can see we had authentication on behalf of our file server against the domain from the workstation Polar Bear, and Polar Bear happens to be my Ubuntu machine, right? And basically, that was a quick whirlwind tour of everything you can do with SMB over QUIC and how you can set it up and how you can play with it. And basically, I'm quite enthusiastic about this because despite some people thinking that everything in the world is something that you can use via SharePoint or OneDrive, I've seen a lot of applications and use cases where a file share is very, very interesting, but you're always running into that VPN requirements to access Azure file shares, and now you have an ability to actually use SMB over QUIC and get rid of that annoyance and make things a bit more transparent and easier for people to use. So I'm ready and willing to show you whatever you want or whatever questions you have or whatever you want to dive into. I want to listen to your ideas. I want to hear from you, basically. Do you like this as much as I do, or are you like, I don't know? Tell me.